Greetings, everyone. This is Jim Cook. I'm your host today. I am the COO at Wells Engineering, located in the United States, in Florence, Kentucky. That's just around the city of Cincinnati. So if you're ever in the US, look us up. So I'd like to present today a little bit about the digital transformation of the industrial energy sector. Our background at Wells is power engineers. So we tend to lean towards those industries that we serve when we discuss things. However, a lot of these principles we discuss could go into other energy companies like gas or other fuels, or anything that maintains our industrial base. And most of these will apply equally to any industry that uses power at all. Going through this, although it was geared towards the energy industry, I know that many of my industrial customers could likewise benefit from this information. So we're going to dive into the energy sector, the benefits of digital transformation in that area. So I'd like to start out through thought-provoking survey information. I have a friend who teaches business statistics at a local university. He told me he starts out every semester by telling students 70% of all statistics are made up. Sadly, only a few laugh at his joke. Some think he's actually serious. But with that said, not every statistic is valid by itself. However, in the space of digital transformation, there are many such surveys, and they corroborate with each other and bear some reflection. Anyway, this trending information compiled by the World Energy Council gives some thought. Now remember, this is a global survey, so many of the developing countries are included in this. So you have to take that into account in the survey data and the percentages listed there. I'd like to highlight the one quote here. I think that is very important, and let it sink into your brain a little bit. Over the next decade, we will witness changes tearing through the global economy with unprecedented speed, scale, and force, such that entire systems of production, distribution, and consumption will be transformed. Now, this is a powerful statement. Question is, do you believe it's true? And will it be to this degree or something less? Can you afford not to believe it when developing your new strategy? So actually another piece here in this McKinsey study in the blue shows potential savings in the utility value chain segment, which is what we're touching on today. The four main groups in generation, transmission, and distribution, customer experience, and what I would call the employee or corporate functions of the utilities. So this estimate is a % improvement in operating and maintenance spend in these areas. Generation has the least opportunity. This is likely due to several reasons. First, the shift from coal has obsoleted many of the older assets in the generation area. The newer assets, gas turbines, solar, wind, in the last decades are already highly digitized, having sophisticated data collection and control schemes needed for efficiency of the generator and the grid reliability demanded by NERC. The transmission assets show the largest % chance is they have much older assets, and in many cases, the utilities still have electromechanical relaying. The opportunity to put instruments onto these older assets, collect data, is driving this. However, it should be noted, there is a tipping point. For doing this, we have to reach and possibly replace every relay to an upgrade, something that is more modern so it can communicate. And that costs money, and some utilities don't spend that money without getting rate increases to do so. And on the customer and corporate side of things, the utilities are slow to change and spend as their systems are working and their rates or income are stable. The interesting point here is that COVID-19 may change that as revenues are going to fall, perhaps forcing change for the purpose of saving costs. I recently read one report that indicated COVID-19 will cost the US utility co-ops and munis about $10 billion in revenue by the year 2022. Another indicated the peak demand is down about 20% on most utility sectors that have high reliance on industries that are idled. Some as little as 5%, but many as high as 20%. In fact, I know one steel plant that is not doing too badly, but it's taking extra maintenance days just because its demand is slightly off. And that alone, we've calculated from the metering data that we're using, is about a 10% decrease in them for consumption. So touching on these four, the interesting part here, this is the customer journey for a utility. So that's kind of that corporate and customer piece that was listed there. This is what it looks like broken down in this study that we pulled. Much of the processes are part of larger software systems the utilities use, for customer interaction, for maintenance. Much of this consumer interface is through the web or a lot of times through the company call centers. There's an immense amount of data that is collected, though. From this, a utility can forge better customer relationships, project consumption by users, correlate weather events to usage and outage information, target conservation efforts directly to users, and initiate maintenance efforts that can determine root causes. Much of this data collected is already using things like data analytics, as it was a necessity. For instance, utilities can project with great accuracy the consumer consumption based on the time of year, day of week, and the weather that day. This, of course, was a necessity as residential meters have high failure rates. For many years were not networked. So the only time the utility knew there was a failure with the meter is when the meter reader showed up to read it. So they developed these statistical systems to avoid revenue loss. However, there's still a large amount of data and information collected through this experience that once machine learning is applied may enhance the existing systems and provide even more valuable information to other parts of the utility process. So all utilities are part of the process and even all the equipment. So any factory needs energy and the other utilities for its operation. Electricity, water, thermal, gas, etc. are all part of this. There are various opportunities of improvement in these systems by means of digitization. Basically, we not only have to consider the energy industry from a substation point of view, but the equipment that is consuming the energy needs to be integrated digitally as well. So let's take a look at ISO standard 50001, which is the energy management standard. So it is a systematic approach for continuous improvement of energy performance, including energy efficiency, energy security, energy use, and energy consumption. Digitization makes this process efficient by providing actual measured data, which is the backbone of plan, do, check, and act, which those of you familiar with continuous improvement processes are quite familiar with those words. So imagine just taking things like training and work instructions digitally. That will add another wave of improvements to this. In essence, digitization is a great way to enable improvements you are seeking, and it may look something like this. So I find it interesting at the depth at which it can go digital. The question always remains return on investment. How deep do you go and how will you know if it will work? If I had the unlimited budget and knew there were no risks, then my decision would be easy. We'd all have a lot more fun playing in the digital world, of course. The critical part of your planning your digital journey is the audit process. From this, you can develop a plan for your journey that can be done with smaller projects over time. And we can, can be extended or contracted depending on the strategy of the company and other issues like your competitive pressures. When you take the small project approach linked with the best practices of ISO 50001, you confirm the return on investment of each project and its rate of success. This builds trust in the continued investment process with upper management. This greatly simplifies the implementation and reduces the risk. I believe that many American companies have nagging doubts because of their experience in things like implementing ERP systems and the resounding failure in getting benefits they were told they would get. The statistics industry in the US is that less than 15% of ERP systems, of these giant expensive ERP systems, have never yielded the outcome the purchaser desired. But the digital segmentation approach does not involve the whole enterprise, and we can greatly reduce risks for implementation. So here's a simple process applied to distribution system, whether it's a utility or industrial, you can decide. So we're going to walk down this a little bit. The beauty of digital is that its ability to interface with existing systems instead of replacing them. And that is where things like ERP systems cause difficulty. Many times replacement is needed, so that can be done as well, but most of the time existing systems can survive and thrive in our digital world. For instance, existing SCADA systems, metering, and other instrumentations have always provided information to us in pieces, and now they can be collected and analyzed to gain new insights into optimizing performance. So for instance, if you're a utility and you have a Maximo asset management system that tracks your assets and its maintenance records and determines where work orders are going to go, this is good and it's fully functioning and working, leave it alone. Maybe consider adding augmented reality or virtual reality work instructions tied to that system. Or take your power quality data that you have from your existing system, add some sophisticated data analytics and, or machine learning, and learn how to predict future problems better. So let's dive a little deeper. Part of the plan is to perform energy audits of your facility and report out. This process currently is highly manual in some cases. We can digitize parts of this process that will provide actual verification using data and integrated checklists that greatly speed the auditing process. And this work can be easily performed without having to engage some engineer or some outside company. This becomes the fundamental part of the plan, and plan, do, check, and act, as we mentioned in the ISO standard. We are already seeing a huge growth in video training across types of industries to develop personnel. Companies are seeing great benefit with this training. Power systems can be complex, and equipment ages cover many decades from the 70s to today, as does the technology, from solid state to electromechanical relaying for things like protection systems. It's not uncommon for me to be working with clients whose assets date back to the 1970s. A truly digitally integrated environment would take current training practices and classes that you have in your company, convert those to video, let's say. Then we would add things like power system drawings and all the drawings associated with that. Take in the OEM drawings of the equipment manufacturer. Add in industrial standards, whether they be from IEEE or NETA, for instance, and practices that you also find out in those industry specific areas. Then we can create a interactive self-paced learning environment. Asset information then can be easily accessed and tied to a 3D layout, and all that information accessible visually and interactively through that layout. Another good application is for preventative maintenance routines on equipment. Augmented reality can indicate all the visual inspection points of a machine when you walk up to it and select that machine on a screen, and can take the user directly to retraining if they need any or have questions about what they're looking at. So the virtual factory, that 3D model I had mentioned, this allows the visualization of the factory in a new way. Things are easier to see, it seems, when it's laid out. You could measure peak shaving by equipment by its time use and when it's used during the day, and maybe shift it to an off shift because it's a high energy consumption and it's during peak demand periods with the utility. You can understand potential equipment upgrades and improvements. You can identify idle equipment that may be powered but not producing. And then you can set up energy consumptions and alerts for each of these pieces of equipment. So in the AR, VR world, imagine step-by-step instructions for technicians when they're doing something like, say, testing a relay in a substation. You could clearly identify what connections to short on that relay before you begin to test with it. Perhaps it will tell you how to hook up the leads to make sure you do that properly and you have the proper polarity set in place. And it could also give you some hints on how to use the testing software and how to process that test. Imagine virtual, easy to access reference manuals from the manufacturer of that relay with a click of a button. You can check a replacement parts inventory back in the spares shop because the relay is not testing good. Or you can collect the testing information and download it live right there, and then see trending with prior testing. Also, these relays are coordinated with other relays. You can pull up the coordination data for those relays. And then again, the nameplate data of each of these are critical and important in how they interact with each other, and you'd be able to virtually do that. And then add in integrated help screens that can take you to training modules to help teach you pieces if you lack them, thereby accelerating the learning curve of younger people who are doing this testing. It's all very powerful, especially to those of us who've been in the field wishing that we had that information, and I can tell you that has happened to me many times. So let's talk about some other things like analysis. The collection and analysis of data is critical in making improvements. Here you see the analytics rolling up into a dashboard. It has high-level summary information with it, with drill-down capability that can take you all the way down to the machine level and even to the gauge or the instrumentation that you're reading from. With this, you can identify energy thieves in your electrical system and see it visually. And you can capture actual cost data of a piece of equipment. If you can promote activity-based costing in your system, you can really figure out what each process is costing you instead of using an average cost system. And things like this will help do that. The digital world could greatly change how most companies do accounting, in fact. And equipment maintenance systems with asset management can be provided or integrate with existing systems. So like I mentioned before, a Maximo system will do a maintenance, or people like MaxBite offer their own system version that can be integrated if the client doesn't have one. Digital inputs allow for the correlation between production event data and energy, allowing for greater understanding of power quality events for things like nuisance trips, power quality issues like flicker. So many times I'm out with a client, something trips off at the utility. There's all kinds of measuring data out there, but a lot of times they may not know what caused it because they don't have a tie-in back to the operations of a large consumer, let's say. If we gain knowledge of what was operating in the large consumer, that could lead to understanding of what caused it and if adjustments need to be made in the system to improve reliability. So, and again, other things like condition-based maintenance data can be collected, and that's sent to analytics. It will drive a new maintenance program, or including predictive maintenance, which can reduce overall costs. From the prior equipment data collection, analytics can be used to develop projections for potential failures and when they might occur. This information can be wrapped in a package that can provide tracking of root cause and corrective action, or a corrective action requests or preventive action requests that can come in. So this ensures the quality loop. In fact, this is a system here that's just done within by MaxBite that helps in tracking all those and ensuring that the quality loop is closed and everything that is entered is finished. Additionally, if you group similar equipment types, say you got transformers from the same manufacturer, same type and size all over your plant, you can aggregate that information and build an FMEA projection for future developments. Same goes within a substation as well. In fact, many utilities have fairly standardized suppliers. They'd be able to collect all that data real time, feed that back up, and determine if their supplier choice had issues or problems. So we'll go through a couple examples here. So this is a distribution feeder. Now this could be simple utility level, or it could even be on an industrial level who has a larger distribution feed. The machine learning algorithm can predict potential failures. And what it does, if you notice on the left, it looks at things like SCADA data, historical anomalies, maintenance and inspection work, construction characteristics, geography, weather, and measurements of power quality. These, especially the real data like power quality meter, can lead to robust prediction methods for problems in the power system. And of course, the more real data you collect, the better you can predict as well. So why should we care? To answer this, we have to go back to the beginning and ask, do you believe that digitizing your processes could radically change things? Will it make you more effective and efficient, delivering energy at lower cost? Can the predictive nature of good data and machine learning reduce risks and enable faster decisions? If you believe this, you have to care. You are out of options. The next question is of timing. Is it too late? Early adopters will gain a huge advantage over their competitors, and the speed at which this happens will create a large separation from those who are slow to adopt. By reducing risks in this process, we can enable agility even in companies that are not agile now. The real issue is, can the company culture allow this agility to happen? In 10 years or sooner, we'll know that answer for many. So the question becomes, how do you initiate these changes with your company? Some experts claiming significant benefits, as you see mentioned above in this slide. The World Economic Forum estimates back in 2016 that the estimated worldwide benefits from digitizing of power alone would be $1.3 trillion over 9 years. They estimated the cost savings at 986 billion US dollars. And they estimated the net job creation for digitizing the grid at $271 billion in payroll. So we already see these trends coming true with the federally mandated network optimization and the aggregation requirements from groups like NERC. These business cases become the foundation for obtaining a strategic initiative to start your first digital transformation. This is your call to action. Find a small project with reduced risk to prove digitization works, then measure the results and prove for the next case a higher risk level. So to do this, we have to look at the process again. The transformation of the energy industry has both breadth and depth in terms of application. In this cycle, we need to measure and collect data on how energy is used, use machine learning to spot the potential savings. These analytics give us solid projections to fill our business cases. And after implementation, verification is achieved by measuring the exact results. This becomes the method for which we prove the next investment and convince our management and owners of doing it. So the mission is to take one bite at a time, prove the worth of an improvement by measuring, then attacking the next project and doing the same. Few companies have the luxury in time or capital to do it all at once. This is why a planned approach with solid metrics can work for today's engineers tackling digital transformation. After seeing the possibilities in this industry, how do you rate yourself now on a scale of 1 to 10? With that, I thank you for your time and for listening.